Today we are going to talk about this year's Nobel Prize in Physics, which is given to the three excellent scientists. Professor Agostini, who is from Ohio State University, USA. The second is Professor Frank Koch, who is from Max Planck Institute of Quantum Optics. And the third one is Annie Euler. They have got the prize for experimental methods to generate attosecond pulses to study the electron dynamics inside an atom. So to understand this in very simple terms, let us see. As we know, the hummingbird, it beats its wings maybe around 80 to 90 times in a minute, which is very fast. So from our eyes, we are not able to see the wings when a hummingbird flips them. So to capture a focused image of these fast moving objects, you need to have a high shutter speed of your camera. That means that you see those events in a way that your capability of seeing is also of the order of the speed of those moving objects. So similarly, atoms, they vibrate at a very fast speed. So it is very difficult for us to understand their dynamics. Until now, before the invention of this attosecond pulses in 1987, we had the femtosecond lasers. To understand even the dynamics of electron which is inside atom, and they even vibrate or move even faster than atoms, which is beyond femtoseconds. So whatever femtosecond photography, which is supposed to be the limit of photography, is not capable enough to study the dynamics of electrons. So to study the dynamics of electron, we even have to go one step beyond, which is attosecond lasers. And how we have come up to that is in 1987, Professor Euler, she did an experiment in which she has passed the multiple wavelength laser through Nobel gases, and there she has noticed something which is we call overtones. So those overtones we were able to get the attosecond pulses. Later in 2001, the other two professors, they have done the experiments, and Professor Frank Koch, who is in Max Planck, he has created a light pulse which lasted for 658 attoseconds, and another professor who has done the experiment and created a pulse with 250 attoseconds. So those were the fundamental discoveries at that time, and later they have started looking for the application of these particular discoveries, and they have many applications, especially in the field of let's say medicine. So using these, you can study the dynamics of various molecules, and you can design drugs for, let's say, cancer therapy or some other critical disease. Another application is of course the photography of electron, in very simple words. So you can study the dynamics, how an electron is moving, how it is interacting, how it is going out of an atom and again coming back, and all those interactions you can study, and it is much helpful. And also attosecond chemistry. So there also you need to study various molecular dynamics, which can be much more easier with this attosecond pulses. And other than that, also in the field of electronics, nowadays whatever computers we are having, all of them are having electronic circuits. So all these professors, they have estimated that if these pulses could be used in the right direction, the speed of current computers could be increased by million times. So that is pretty significant. So in this sense, I think this year's Nobel Prize is given to a very excellent candidates, excellent discovery in the field of physics, which is attophysics, and I hope that this discovery will put a word out, and new young minds might be interested in physics, maybe for attosecond.